Hi everyone, I'm Erin Carswell, Vice President of Exploration at Foran Mining, and I'm really excited to be here today to provide the first update from the winter 2024 drilling season, where we're going to look at the first 4 drill holes completed and how we've already managed to expand Tesla significantly and learnt a lot more about the geometry of the bridge zone in the process. So please pause the video on this slide if you need to read more about our disclaimers around forward-looking statements. We're going to start off at the claim scale here and zoom down into our McIlvenna Bay deposit, which most of you will know has a 44 million tonne indicated and inferred resource around it, making it already one of the larger volcanic hosted massive sulphide deposits of the Flin-Flon Greenstone Belt. You can also see on the screen here the projection of the McIlvenna Bay ore body to surface in red, with to the north the approximate outlines of Tesla and the bridge zone, both which are relatively new near mine discoveries that we're still in the process of drilling out. So I'm just bringing up here a map of our 2024 winter drilling plan, and you can see here that, we're going pretty hard. We've got 6 drill rigs out on the ice at the moment, and the real reason for this is that we only get a relatively short, maybe 2.5 months if we're lucky, period where the lake ice is frozen enough to have drill rigs out on it, and that allows us to actually drill Tesla in the bridge zone from the optimal angles by using that frozen ground. So the holes that we'll be discussing today, I'm going to highlight them in marker. So the 4 that we've completed, we're starting off down here in the bridge zone. And then we've also got a couple of Tesla up dip holes, nice little short ones drilled from the ice that we're going to talk about as well. So dropping beneath the ground here, and what you can see here again is our drilling traces with McIlvenna Bay on the right, Tesla on the left, and the bridge zone in the middle there with the grey traces. And the red intervals on these drill holes represent mineralized zones. So this is not assays, but it's anything logged as copper and or zinc mineralization. And simplifying it like this for today is going to let me talk more to the broad geometry of these zones rather than looking at assays with specific lenses or zonations within them. So let's look at the first 2 drill holes of the season. So these MB 24290 and 292 that you can see on the screen here. Now, these were quite interesting. We drilled these initially to test the edges of the bridge zone where we expect it to meet Tesla in the north and McIlvenna Bay in the south. The point was to obtain important structural information that could help us understand the geometry and the controls on the bridge zone itself. And we often say in exploration geology that the edges of mineralization tell us more than the center. So starting at the outside and kind of working our way in is certainly a strategy that we want to employ to understand complex zones like this. And as with so much of our drilling at Tesla and the bridge, the results have been pleasantly surprising. So both holes made 2 mineralized intercepts. And I should note that we currently only have lab assays for the upper zones in each. The rest will come out with the subsequent press release. And this hole that I'm about to highlight here, which is MB 24290, just there, made an absolutely beautiful intersection into what was actually the Tesla horizon. Some quite significant assay results that you can read from the screen there. So immediately this tells us that the Tesla horizon extends an additional 140 metres further to the southeast than we'd anticipated before it bends around into the bridge zone. So overall, Tesla now measures longer than 1 kilometre in strike length, which is even bigger than the original EM anomaly that we used to target the zone. And we still haven't found the edges of it. It's still going. So what we're going to do now is look at a couple of 3D shapes that are going to start to build the picture of how these different zones fit together. So we're zooming back out and kind of looking down in a bird's eye view here at McIlvenna Bay, the bridge zone and Tesla. And what you can see in grey are 2 different shapes. The first on the right, where you can see the higher drill density, that's effectively the outline of the McIlvenna Bay resource. The second, around Tesla and the bridge, is a very preliminary work in progress shape that follows the Tesla main lens. And I'll point out that this is not a resource. This is just a way of us to make sense of the geology as we see it so far. Now, we've known for a while that the bridge zone represents a structurally complex link, probably a fold, between Tesla and McIlvenna Bay. And one interesting development in this latest drilling is that the fold amplitude is actually higher than we expected. And I'm going to try and show this again with markers on the screen here. Bear with me. So initially we had assumed that Tesla came along like this and kind of tracked through with a gentle fold to join up with McIlvenna Bay here. And what we can actually see instead is that Tesla continues further than what we expected and then wraps around a little bit more dramatically towards McIlvenna Bay. So what this does is open up space. You can see that we need to do a little bit more infill drilling at Tesla in that gap between 290 and the nearest Tesla hole. But it also opens up a bit of extra space in the bridge zone too. So quite an interesting finding there. But we're also learning more with this latest drilling about the structures that control the bridge zone. So at the southern end, where the bridge meets McIlvenna Bay, we now know that a major fault cuts through this area, which I'm going to draw in a second, which actually leaves open the possibility that McIlvenna Bay continues. So I'm going to try and draw this on the screen. We know that the fault, and we see this in drill holes, comes through a little bit like this, leaving open the possibility that McIlvenna Bay continues to plunge off in this direction. And now the new drilling that we have towards Tesla has actually allowed us to put together some drill hole observations that show another parallel fault. This time cutting through a little bit like this, also leaving open the possibility that Tesla could continue along that northern side of the fault. But what it shows beautifully is actually that we're looking at the bridge zone being almost like a fault-bound kind of block between Tesla and McIlvenna Bay. You can see drag folds kind of coming into the faults, which is really interesting. And the other cool thing from our perspective is that we're starting to ask questions about, well, if it is, between two parallel faults like this, what's the possibility that we've got mineralized transfer structures between them as well? And so we're starting to look at some of these interesting structures that are mineralized, also in McIlvenna Bay, and new kind of, zones of mineralization that are starting to hang together in this zone that are separate from the kind of main lens. So there's a lot more understanding that we need to build through future drilling in this zone. Watch this space. Hopefully we'll be able to, at the end of the winter program, put out more of a 3D model showing these structures in a little bit more detail. Anyway, so that was the two bridge holes. We're going to zoom now back to the northern end of Tesla in section, where I've taken McIlvenna Bay off this view just so you can see the simple Tesla view. This is looking down the barrel of Tesla towards the south. And the two holes that you can see there with the aqua traces are TS2317 and TS2318, which were drilled to start testing the up-dip extensions of the Tesla main lens. Now, we don't have the assays back yet, but there is significant visible sphalerite and chalcopyrite in these mineralized zones, confirmed that we definitely have copper and zinc in these areas, confirmed by using the TrueScan XRF system. And what it actually means, and I'm going to, again, grab the marker here. If you recall from my last video, we've confirmed that the Tesla lenses dip off towards the northeast a little bit like this. So this is effectively the Tesla main lens. What we've done here is add an extra 160, 170 meters of up-dip extension of the Tesla main lens, which is really significant. We still haven't cut this thing off. And the potential for shallower mineralization is actually, something that we're going to start to explore with a lot more impetus, I suppose, over the coming winter and summer programs as well. And then, of course, when we spin around along strike, you can see these holes from a different perspective. We know from the borehole EM that we've recently completed on these holes that we also have a continuation of mineralization. I'll grab the marker again here, along strike in this direction too, in the up dip, which is very cool. So we do have a lot more drilling to do here to kind of, put numbers around all of this. But certainly the big thing from our perspective is that no matter where we drill Tesla, we cannot close it out. We've not managed to drill the hole that's missed yet, which is super exciting for our team. Zooming back out, and I'll just close on this slide because you can see the exciting holes that are yet to come. We've only drilled 4 of these so far, or at least we've only completed 4 that we're releasing to the market now. There's a lot more to come this winter, so please stay tuned, and I look forward to updating you as we go forward. Thank you.